Hello everyone, myself Dr. Padala Rajshekhar, Assistant Professor, Department of Civil Engineering and SR University, Warangal, India. So today I have came with another series of lecture. Like previously you can see in my YouTube channel, Hydrology and Water Resource Engineering. And this semester, like this time, I'm going to teach you fluid mechanics and hydraulic machines. So there will be a series of lectures, and first basic thing in any kind of subject, first when we are dealing with title like fluid mechanics and hydraulic machines, like kind of some any kind of subject, it may be hydrology, it may be irrigation, it may be fluid mechanics or remote sensing or watershed management, whatever it may be. First, the students need to understand about the title. First, title is important for anything. If you understand properly title and if you are able to know, then whatever the concept it's taught by faculty or taught by someone, you can understand easily. So first, my concern is also that fluid mechanics and hydraulic machines. So first, I need why we have to study this subject and what is the importance of this subject. So, as you people knows, the subject is mostly engineering fit domain, which is dominated in civil and mechanical. But here we don't know that other thing. This is also fluid mechanics, also applicable in science like physics, mathematics, chemistry, and biology. And not only that, in engineering segments, chemical, metallurgy, aerospace also it is applicable. Fluid is everywhere. It will be in three ways. One is in liquid form, where we can see and we are like your water which we are drinking, that is liquid form, and so a solid form, that is snow. And another one is vapor, which is not visible, but you can see my previous lectures, hydrology and water resource engineering. There will be a vapor like from transpiration or evaporation process on the surface, the water will escape from land to the clouds. There will be a mediator called vapor. The water is turned to vapor and it will reach to the clouds, and again condensation, again it will fall back as the rainfall. It's a cycle, so continuous process. So here the one thing is that vapor is also very important. That's what aerospace and this chemistry, these all things are there. So now we will see one by one, like in science domain. Other than civil, we should understand this is particularly dominated to civil, but even though we should understand the other concepts. So now coming to the physics. Here I have given a simple words you can understand. In physics, explains how fluids behave under forces, like maybe some pressure, gravity, velocity, and flow rate. If you are able to understand the basic things like Bernoulli's Archimedes. Archimedes is nothing but you have considered 1 liter of water and you put some weight, and the weight, whatever the weight of that stone or whatever the thing, when you are placing in that water, it will be displaced. That same amount of weight is displaced. So that is called Archimedes, that we will see in the upcoming lectures in an in-depth concept. So like that means explains how fluid behaves under forces: pressure, gravity, velocity, and flow rate. Flow rate means discharge, velocity means meter per second, gravity you people knows, pressure, force by area, how much force with respect to that particular area. And coming to the mathematics, provides equations like continuity equation. This is you people need to know about continuity equation. Like in a simple sense, as mathematics, left hand side is always should be equal to right hand side. LHS equal to RHS. That is nothing but continuity. In terms of discharge, A1 V1 equal to A2 V2. So provides equation to model and solve fluid problems accurately. So in another format, chemistry. So this is another segment helps understand mixing, flow and reactions in liquids and gases. So in chemistry, you people can understanding the mixing and as well as the flow and reactions in liquids and gases. And whereas biology, it can be seen describes flow of fluids like blood and air in living organisms and medical systems. So you people can understand blood and air in a living organism, how they are flowing from one place to other place. It is also a form of liquid in a medical system. So you people there we can understand the fluid mechanics. And coming to the engineering background, civil and mechanical mostly focused in design, like used in design of water supply, pipelines, pumps and turbines. See, we are constructed one some structure, some water storage structure. So like maybe check dam, not check dam exactly, you can take a reservoir. So we have to transport the water from one place to other place. So you people need to understand the pumps, like pipes, pipelines and pumps and the water supply system. That means from one place to other place, how it is transferred from one place to other place without any damages in the sense major losses, minor losses. So major losses is mostly with respect to the friction. So that we will see in upcoming slides, what is friction, what is viscosity and some fluid properties. Then you people can understand some internal losses which usually we have to consider it. They we have to reduce the losses. So in turbines, you people know to generate, like it may be centrifugal turbine or Pelton centrifugal pump or reciprocating pumps in terms of pumps, and in terms of turbines, it is a Pelton turbine or Francis turbine. Like kind of things are there which we will cover in hydraulic area. And coming to the engineering part, another thing, chemical, metallurgy and aerospace. So chemistry is different and chemical is different. So chemical, metallurgy and aerospace applies to fluid transport. So applies to fluid transport one place to other place, and metal casting, metallurgy and airflow in aircraft and rockets. As I mentioned previously, the water or a liquid or a fluid having three phases, like three types. One is liquid form, one is solid form. Liquid form is a water and solid form is a snow and vapor. Vapor is nothing but in air we can see the vapor which is escaping from ground to atmosphere for to make a cycle process called hydrological cycle. So when we are making a rocket or aircraft, so airflow in that particular space we have to understand. So these are the broad domains where fluid mechanics and hydraulics is applied. So now understanding these things are very essential before going into the topic of civil engineering, particular civil engineering domain, fluid mechanics and hydraulics. So as I mentioned, first we have to understand the importance why we are studying this subject, because we think that this subject is only applicable for civil. No, it is applicable for mechanical, chemical, metallurgy, aerospace, physics, mathematics, chemistry and biology. In a broad view, I can tell science and engineering. So that thing we have to understand in a precise way. And next thing, why do civil engineers study fluids? As I mentioned, engineering and science people are studying these fluids, and particularly why civil engineers are studying. So here you can see the images, three images. From this you people can understand easily. So to make a easy understanding, I have given the images. So one, water distribution. So to distribute a water from one place to other place, maybe the source is maybe from pond or lake or a reservoir, we should understand. So then only fluids, then only we can distribute. And hydraulics, and coming to the flood control. So let's see one after one how we are interlinked. So now coming to the three categories I have considered, it may be more, but to easily understand I have considered these things. Now coming to the air. So air is a fluid, obviously. So everyone will agree. Air is a fluid. As I mentioned, fluid is in vapor. So civil engineers design buildings, right? Agree. Civil engineers will design buildings, bridges, and towers. So they are tall structures. Now these structures faces wind pressure. Obviously, if you are increasing 10 floors, 20 floors, 30 floors building, so wind pressure always won't be similar when you are on the ground and when you are going into the higher floors. So knowing fluid mechanics helps them make sure the structure stays safe and stable in wind. So that is what the concept. So understanding fluid mechanics always makes it stable the structure as well as the safe in wind terms. So example, Burj Khalifa used wind tunnels testing to reduce wind impact on the structure. That is one of the best example. And coming to the another one, second one, water. So civil engineers work on water related projects. So they need to understand how water flows and behaves in different situations. That means in different situation means you can take some water is transporting from one place to other place, that is what required, because city, if a city or a if a city which they built on the banks of the river, okay, there won't be any kind of quantity of water issue, but there will be a issue with the quality of water in some cases. So they will tackle with respect to the quality aspects. But when a city is growing, but water maybe the city is not on the banks of the river, or the banks of the river may be not sufficient for the city expansion, then they have to depend on far away distance. So this distance they want to transport the water from one location to other location, then they have to see cost effective as well as the time, as well as how much water they are getting, how much they are able to store in reservoir. So they need to understand how water flows and behaves in different situations. Like example, smart city projects, like simulate rainwater flow to prevent urban flooding. It is also the best example you can see. Rainwater flow to prevent urban flooding means if all buildings having recharge rainwater and harvesting pits, that means somehow we are reducing burden on the city in terms of flooding. So and proper drainage works, this all kinds will comes into the water. And coming to the third one, hydraulic structures. So dams, you people knows this about dams, canals, drainage systems, all involve moving water. So one place to other place, that is called hydraulic structure. Civil engineers uses fluid mechanics to control how water flows through these structures safely and effectively. Example, Sardar Sarovar Dam uses spillway design to control flood water safely. Now coming to the, now we understood the importance. Now we understood the forms like air, water, hydraulic. Now next one is third one, development of fluid mechanics. So here need to understand how it got developed. Fluid mechanics. First, we have to, for any kind of thing, we should know the past history. What happened in the past, what changes made in modern, then what the present scenario, and what we can do for the future. These things, if you are able to understand, then tackling the problems with respect to fluid mechanics is very easy. So first of all, I want to discuss fluid mechanics. So fluid mechanics is a science that studies how liquids and gases behave both when they are still at rest and when they are moving in motion. As I mentioned, liquids means water, you can consider solid means it is a snow, and gaseous means vapor. So studying liquid and gaseous in terms of at rest, if they are at rest, what do you mean by rest? What do you mean by motion? So at rest means you can see a water tank which is able to supply for an entire house. So we will place that water tank on the roof of the building. So that is at constant, and it is having some amount of water in a stationary way, but always filling and taking. We are filling the water tank and we are utilizing for our things. So when it is at rest, what is the consequences? We have to understand. And when it is in the moving, like one reservoir to certain city, if we are supplying a water, then what is the consequences? Like consequences means in the sense of in the sense that we are making losses, less losses, and low cost. We have to focus. So people faced many problems related to water supply, irrigation, transportation on water, and using water power. So initially, this is not the problem which evolved right now. It was there from past. If they want to do some irrigation, they are able to do in the past because they need some river nearby. So always it is not good for all the people, because everyone won't get land nearby the river. Some will get far, so they have to route the canals. So it will be very difficult, and these problems led to development of fluid mechanics. So they understood something is there to study, then it came in the fluid mechanics. As I mentioned earlier, Archimedes around 250 BC. People can understand 250 BC, man. Now we are in 2025. 250 BC. 225. So 2275 years ago, Archimedes given a principle which is still valid today. That means, as I mentioned, there is some water. The water is displaced with respect to the weight of the object. So after that 250, nearly 700 years after that, the Roman Empire collapsed. There wasn't much progress until around 1500 AD. So up to Roman Empire, it was there, good research has gone. So after that, there wasn't much progress. 1500 AD. Who made some early designs related to Leonardo Leonardo da Vinci. Fluid flow, like canal locks. So until Da Vinci's time, fluid mechanics was more than an art than a science. So they treated initially it was an art, they felt, but it was not science, they thought. Now coming to the another, about 200 years ago, now we are 2025, so 200 years ago means 1800, like that you can consider. The knowledge of fluids became more scientific and split into two main branches. One is classical hydrodynamics, another one is hydraulics. So classical hydrodynamics means focus on theory and max. So some theory and some related kind of max, maybe continuity, like that. Hydraulics means focus on real life applications and experiments. So that is what we have to understand. Hydraulics is real life applications and experiments. Now, the modern fluid mechanics provides this new approach and taking a balanced view of both the theorists and the experiments. Now, that means we have to give value for theory as well as the experiments. So, modern fluids made theory plus experiments at one place. The generally recognized founder of the modern fluid mechanics is the German professor Ludwig Brandt. His most notable contribution being the boundary layer theory, which has led which has had a tremendous influence upon the understanding of the problems involving fluid motion. So he has focused on boundary layer which is having fluid motion. That is very good thing. Now, just I want to make in a simple things. So I have summarized development of fluid mechanics. Like this is a development of first fluid, next Archimedes 250, next Roman Empire, next after Leonardo da Vinci, next 200 years they were classified into classical hydrodynamics and hydraulics. Then the German professor Ludwig Prandtl. Now coming to the development of fluid mechanics. So just you can see here 250 BC, it was Archimedes principle established. 15 Leonardo Vinci's early fluid flow designs. Last 200 years ago, division into classical hydrodynamics and hydraulics. And modern area, Ludwig Prandtl's boundary layer theory. And I want to give some reference books which is not restricted, but they are the latest versions. If you need, you people can go through these. If not, you people can go with your own choice or someone suggested one. There won't be any kind of force. Just we have to gain the knowledge. Now coming to the what is mechanics. So we know fluid, right? So we know fluid. Now what is mechanics? So mechanics means just the term you people can understand. Fluid mechanics is broadly classified into two ways: solid mechanics and fluid mechanics. So now we will see the definition of mechanics. Mechanics is a branch of physics that deals with the motion and forces on bodies. A branch of physics that deals with the motion and forces on the bodies. So it is with respect to motion as well as with respect to forces on the bodies. Now slowly we will go one more step, that is called static and dynamic. You can see both having solid mechanics and fluid mechanics having static dynamic, and fluid mechanics further is divided into dynamics into kinematics and dynamics. So now we can see solid mechanics is nothing but a branch of mechanics that deals with the behavior of solid materials under force. Solid itself defines solid materials. So here they are going with respect to the force. So a branch of mechanics that deals with the behavior of solid materials under force. And next one, fluid mechanics. That means a branch of mechanics that deals with the behavior of liquids and gases. So obviously this is what we need. We are not going with any kind of solid materials under force. So we are going with liquid things. It may be liquid or it may be gaseous. So we have to understand when it is in static position, that means rest. When it is dynamic position, when it is in motion. That is what fluid mechanics defines. You can see the previous definition. Fluid, here you can see fluid mechanics is a science that studies how liquids and gases behave both when they are still at rest and when they are moving in motion. That is what here, when they are at rest and when they are in motion. So this is what the subclassification of mechanics. Mechanics means something is happening. So as I mentioned, solid mechanics and fluid mechanics. So solid mechanics means solid material under pressure or force. So here fluid mechanics means static and dynamic. Okay, now we will see small difference, then we will go completely with respect to solid. So left side, when you are observing these two tables, fluid, a substance that flows and deforms continuously under applied shear stress, is called fluid, and a substance that retains its shape and resists deformation. That means it will go resist for example, you take the honey, so it will keep on moving, but you see solid, it won't change the shape, it will resist the deformation. That is what the difference. Now takes the shape of the container and has a defined shape, so it is having some, not having the shape, but it is having a defined shape. And coming to the fluid, continuous deformation under shear stress. Stress means something we are applying the pressure. So solid means deforms only up to a point. Now fluid is nothing but molecules are loosely packed and can move freely. So here solid means molecules are tightly packed in a fixed structure. In a fixed structure. So they are loosely packed, can move freely. As I told, the best example is honey. And here molecules are tightly packed in a fixed structure. They mean they want to study about the solid material, so they don't want to make it as a loose material. So fluid and solids having both contradictory. So now, in a simple sense, if you want to understand, I have given a figure. Fluid and solids. Fluids means loosely arranged particles, and solids means tightly packed particles, and adaptable shape. It can adapt any kind of shape and it is a fixed shape. So from table to image you people can understand easily. So fluid is something we told flow from one reservoir to a city. If we want to supply some water we can supply, but solid we cannot make that much because it resists the thing. So now we are slowly going into fluid mechanics. So the branch of fluid mechanics is, as I mentioned, static and dynamics. Again, dynamics is divided into fluid kinematic and fluid dynamics. So here you people can understand statics. The study of fluids at rest. Static means you are in a steady position. That is the study of fluids at rest. Example, water pressure at the bottom of a tank. So that's what I want to tell you, water pressure at the bottom of the tank. And dynamics is nothing but the study of fluids in motion. The study of fluids in a motion. The water flowing through a pipe. Water flowing through a pipe. Now coming to the thing, fluid kinematics. The study of fluid motion without considering the forces causing motion. So the study of fluids motion without considering the forces causing the motion, water moving in a river, that you can take the best example. And fluid dynamics is nothing but the study of fluid by considering the forces acting, the study of fluid motion by considering the forces acting on the fluid. Now the best example is that water jet hitting a wall. So if I tell like theory you people cannot understand, so I want to show some kind of images such that you people can understand easily in terms of static and dynamic. So static you people can see here, plastic water tank you can see here, right? This is the, here you can see some water we are storing. It is a static, how much load it is able to bear. And here we will construct RCC water tank. This is another one. And we can see overhead water tanks. Both are overhead water tanks where we constructed to supply for the community near to that particular water tank area, which is essential. So they are all comes under fluid statistics, and these images are taken from Google Images. So that's what I have kept various websites via Google Images. This is not created by me. So plastic, to show the knowledge, to share the knowledge, I am using these images. And branch of fluid mechanics, that is dynamic. You see Indra Sagar Dam in India, you can see this is storing and we can use for multi-purposes. And here you can see this can supply the water, and you can see here the water is coming from water tap and shower, and this is fire. When a fire incident happen, it will sprinkle the water. So these all kinds of fluid dynamics. Now coming to the basic thing called definition of a fluid. Now I have started a subject with fluid mechanics and hydraulics, but I never told the definition of fluid because you people need to understand what is importance, and then coming to the after importance types, like air, water, hydraulics, then coming to the history of fluid mechanics, then coming to the what is mechanics. After mechanics, you people need to understand what is static and dynamic and real time examples. Then only you people can realize definition of a fluid. A fluid is a substance that can flow and take the shape of its container. Obviously, as I mentioned, fluid versus solid. It is having fixed one, it is not having fixed one. It has a no fixed shape but can have a definite volume in the case of liquids, or expand to fill a container in the case of gases. Liquids do not change their volume easily when pressure is applied. So they cannot change easily. They are hard to compress. So their volume changing is not an easy thing. In contrast, gases can be compressed or expanded easily, meaning their volume changes significantly with the changes in pressure and temperature. So one more thing, fluid is categorized as ideal or real. In a simple words, if I want to explain ideal and real, they have no viscosity or surface tension. Real fluids exist in nature and have viscosity and surface tension as well as compressibility. See, now slowly we are entering into the some terminologies which maybe you may not heard about these things. Viscosity, surface tension, as well as compressibility. These all things you people might know. Compression means just we are compressing, that is just a gas cylinder you can take, that is a gas that is compressed. But here the terminology is viscosity, surface tension. These all things we will explain fluid properties in my upcoming lecture. So real fluids you can take in ideal fluids is nothing but there won't be any viscosity, there won't be any surface tension, there won't be any compressibility. But real fluids exist in nature. Nature means whatever we are there surviving, it will be considered everything have viscosity, surface tension and compressibility. Now measurements of fluid, sorry, measurements of a in units of measurements. So units are standard ways to measure physical things like length, mass, time, force, area and volume. So depending on the metrics it has given. So the system of units used in mechanics and are based upon Newton's second law of motion, which states that force equals mass times acceleration. That means force equal to mass into acceleration. That means if we want to find units, so you people need to understand which metric system. Metric system or English system. Metric system is having CGS and MKS. English system is having FPS. Metric CGS means centimeter, gram and seconds. They will measure only in centimeters and grams and measure. MKS means they will measure only in meters, kilogram and seconds. But FPS is nothing but feet, pounds and seconds. So, in the past, scientists and engineers around the world used different systems of units like the metric system or the English system initially. There is a often caused confusion and errors, especially international communication and collaboration. For example, they will tell feet, we will tell meters. So there will be always confusion. To solve this problem, during the 11th General Conference on Weights and Measures held in Paris in 1960, it was decided to adopt a single standard system for everyone to use. This system is called International System of Units, ISU, that is commonly known as SI units, International System. So worldwide they are using this system. You can see a SI base units length. If you are measuring the length, the unit is meter and symbol is M. If you are measuring mass, the unit is kilogram and symbol is kg. If you are want to measure the time, seconds and yes, and electric current means ampere A, and thermodynamic temperature means Kelvin K, and luminous intensity means candela CD. For example, according to the Newton's second law, force equal to mass into acceleration, as I mentioned before. So the unit of force is mass means what is the mass? Kg. You note it on kg. What is the acceleration? Acceleration means meter per second. Length by how much distance, acceleration and how within how much time. So m by second square. So 1 Newton equal to 1 kg into 1 meters per second square. So 1 Newton equal to kg meter per second square. That is what. Now next one topic is concept of continuum. The continuum concept assumes that fluids are continuously distributed without gaps. For example, if you want to transport from one place to other place liquid, it will always stick the water molecules and it will travel. You have to assume. And allowing properties to be defined at every point in space and time. So describing a fluid flow quantitatively makes it necessary to assume that flow variables pressure and velocity and fluid properties vary continuously from one point to other point. So it will vary from one point to other point. Properties will vary. Okay. Next we will see the fluid properties. In continuum approach, fluid properties such as density, viscosity. Previously we have seen surface tension and viscosity and temperature and compressibility. Now new terminals also coming. We will discuss each and everything in next upcoming slides with respect to fluid properties. Density, viscosity, thermal conductivity, temperature, etc. can be expressed as continuous function of space and time. So that's what the concept of continuum.